Hello. Today we're going to go over a rate of change example problem. The example problem that we're going to be doing is going to be a function when y equals 3t squared plus t. Alright, our goal is going to be to find the average velocity of a particle in this function over the interval 1 to 3. So let's just write this here. Our average is going to be from time 1 to time 3, and then I'll put this in a different color. We want our instantaneous at, let's do instantaneous when t equals 1. Alright, so we remember that the rate of change formula is f of t2 minus f of t1 over t2 minus t1. Alright, so let's plug in our values. When I look at my average rate of change, this first number listed is going to be my t1, and the second number listed is t2. So 1 is t1 and 3 is t2. So now my rate of change formula becomes f of 3, f of 3 minus f of 1 over 3 minus 1. So when I plug a 3 into my function, I'm plugging a 3 in for that t value and for this t value. So really, let's get a new color. When I say f of 3, I'm saying 3 times 3 squared plus 3. Alright, so 3 squared is 9, so 3 times 9 plus 3. 3 times 9 is 27. 27 plus 3 is 30. So this first value here for f3 is going to be 30. Alright, we're going to do the same kind of thing for f1. We plug a 1 in for every t that we see in my function. And we have 3 times 1 squared. Well, that's just going to be, here, let's write it out. 3 times 1 squared plus 1. 1 squared is just 1, so 3 times 1 is 3. And then we're adding 1. So 3 plus 1 is 4. So our value for f of 1 is going to be 4, and we're subtracting these two. Alright, then on the denominator we have 3 minus 1, that's going to be 2. So simplifying our numerator, 30 minus 4 is going to be 26. 26 over 2, and that is 13. So the rate of change of this function as we go between times 1 and time 3 is going to be increasing at an average of 13 units per second. Alright, let's clear some of the board and talk about how we'd find the instantaneous velocity. We remember from before that the formula for instantaneous velocity is the same as I'm saying velocity. When we say instantaneous velocity, it means the same thing as instantaneous rate of change, so I'm sorry if I interchange between the two. But either which way, the formula for it is going to be the same as the average rate of change, only we're evaluating the limit as t2 approaches t1. In our case, t1 is going to be this number right here, 1. So really, this is the limit as t2 approaches 1. Alright, so then let's fill out the rest of this. This is going to stay f of t2. So f of t2 minus f of 1, since that's what my t1 is in this case, over t2 minus 1. Alright, let's plug in t2 and 1 into our functions for the numerator. So I plug in t2 of my function up here, and I'm going to get 3 t2 squared plus t2 minus, and I'm going to plug a 1 in for both of these t values. And we remember from the last problem, f of 1 in this case is going to be 4. So I plug a 1 in for this t, I get 3 times 1 squared plus 1, which is going to be 4. Alright, and put that all over. This denominator is not going to simplify right now, so we're going to leave it t2 minus 1. Alright, something we might notice is that if I take this limit as t2 approaches 1 and I evaluate this, what I'm going to get is 3 plus 1 minus 4 over 1 minus 1. This is going to be 0 over 0. I definitely don't want that, so we're going to have to kind of change this in a way so that I can probably cancel out something on the bottom so that I don't get a denominator of 0. So let's think for a minute. What can we do? There's nothing we can really do to the bottom because it's just simply t2 minus 1. So I'm looking at the top. I have a trinomial here because I have 3 terms. So let's see if we can try to factor that. So let's erase this. Let's see. So if I have a trinomial, I might be able to factor it like this. Having 3t2 squared in the first term means that one of these will have to be 3t, and the other one will have to be t. Alright, let's see. I need 2 numbers that multiply to get 4, and then when I add them together with the 2 terms I just wrote, they have to equal 1. So I should be able to do that with a, let's see, positive 4. Oops, that's really sloppy. Positive 4 and a negative 1. Try to write these a little bit better. 3t, and this is plus. That's a little better. Alright, so let's see. 3t plus 4 times t minus 1. If I FOIL this out, I'm going to get 3t squared minus 3t plus 4t minus 4. Is that what I want? That is what I want, because minus 3t plus 4t becomes positive 1t. So this indeed is going to be how we're going to factor the numerator. Oops, and I wrote t, but really this is t2. Yep. Alright, and now the denominator is t2 minus 1. So now we see I'm able to cancel these 2 terms. So this cancels with this, and I'm left with the limit as t2 approaches 1 of 3t2 plus 4. So now when we evaluate this function at this limit, I'm going to have 3 times 1 plus 4, which is 7. And that is how we find the instantaneous rate of change.